So, good morning, everyone. Welcome to Carbon Z. So, chemistry in the DC. Introduction. This is basically an exploration of standard data centers and what we can offer. I'm going to take you back to the 1940s, and I'm going to bring you up to date and take you into the future. Back in the 1940s, computers were massive. They would need a room this size. And funnily enough, I was doing some research, sadly, last night at about 11 o'clock. Alan Turing, and everybody knows his computer, Christopher, was in a room this size, this same size as this marquee. So that gives you an idea. That was back in the 1940s-ish, but it was mechanical. Then we went into the 60s. The biggest change in the market there was the mainframe. Suddenly, things have got smaller, about half the size of this room. Then we went to the 80s. We got a PC. And yes, we all probably remember those 17-inch monolith monitors that we used to carry around, which used to balance on top of a desktop. Into the 90s, internet boom. We're starting to get smaller. We're getting flat screen monitors, much better processing, etc. Into the noughties, significant changes, virtualization and the platforms came in at that point, and hyperscalers started to appear on the market. Then we go to 2010, hyperscaler continues to grow, but people are starting to go, hang on, electricity, water, what is going on? We're starting to affect the planet. So, what's the biggest consumables? So I've listed 8 that I can think of straight away. Electricity, top number 1. Trust me, I've seen the bills for the data center on a monthly basis. They make my eyes water. Cooling, a significant proportion of the electricity is in the cooling of the servers, not just the operation of the servers, but to cool a room. Water, you've got to cool the cooling kit. You use the water to transport the heat from the rooms, from the AHUs, out to the cooling trays, and in some cases that's not enough, so you actually start to aspirate them with water sprays as well. And then we'll look at the backup power systems, maintenance, support, security. You get the idea. There's a lot of different consumables. Water-based cooling, this is where it gets really confusing. Water is a far more efficient medium for heat than air. It's around about 4 kilojoules of heat in air, and then in water it's even higher. You then go into the cooling capacity as well. Water has, the best benefit is it transports the heat away. We can use it in cooling towers. We can use it for precision cooling. The obvious one is we can actually run pipes close to a heat source. The water transfers through that copper plate into the water, and away it goes. Very efficient in water-based cooling systems, but they are quite complex, especially if you've got to find a leak. Trust me, those drips never appear on the floor where the leak is in the pipe. But then we go into enhanced cooling efficiency. That's where we actually put the liquid in direct contact with the heat source. We can do that with water, but it goes with a bit of a flash and a firework effect, especially if it's electrically powered. So this enhanced cooling system, which is using oils, which we use in immersion cooling, can actually touch the electrical components. We don't really care about the insulation on the boards and things like that. One of the biggest things that we do get with the enhanced systems, where we're enveloping them all in a liquid, is we don't need fans. Believe it or not, 20% of the power in the server is the fans. By taking that away, your cost, your OPEX to run your server has dropped. So we get a lower energy consumption. But one of the best things about it is we can increase the density. Because we've got 10 times the capacity of heat, 10 times the capacity of heat in the liquid, we can actually run things more dense. And the best thing about it all is less contamination, less corrosion. You don't have problems with dust. You've got no mechanical parts on there, so therefore you're not going to get bearing wear or anything like that. We can compare them, the two methods, water versus oil-based cooling. Immersion-based cooling offers better heat dissipation, which is quite key. The installation of water and also immersion cooling are both complex, but it's different complexities. The water is in the pipework. The immersion is actually in the tanks to hold the fluids. The compatibility issue is quite obvious. Water and electricity doesn't mix. These oils and electricity does, so it's safer. The investment is quite significant. I'm not going to deny that. In either systems, these are not as cheap as dry racks, but they are far cheaper from an OPEX perspective. Water's high heat capacity, it can absorb more and retain its temperature retain that energy before its temperature increases significantly. Mineral oil has a lower heat capacity compared to water. The heat capacity in the oil varies by manufacturer and by oils themselves by that manufacturer. So when you actually come into it and you look at it from a data center perspective, we work out which one's got the best heat capacity, the best heat dissipation, and we do that work for you. The best thing about oil is it's got a higher boiling point and a flash point compared to water. 100 degrees for water, you're talking 170 plus degrees for the oils in some cases. And also the oils are electrically insulating, as I've said there. So combine the systems, we can actually get a really efficient cooling system. We don't want to push the oil all the way out to the cooling systems outside. But what we can do is we actually keep the oil contained in the bath, where the immersion servers are, cool that environment because it's small, and then use water to take the heat from the bath out to the cooling systems. That's a brilliant way to combine it. One of the other benefits of that is that water circuit is actually a closed circuit. So therefore, we're not using thousands and thousands of gallons of water. We literally can be running on a couple hundred litres. One of the other things that it does actually lead into, because you're starting to play with energy and heat, if we take away the word heat and actually just concentrate on energy, we capture that energy in not only the oil, but we also transfer it from the oil into the water, and then we can start reusing it. Are we sustainable, or is this greenwash? Okay, water conservation. We use next to no water. That is fact. In comparison with some of the larger entities, our water is negligible. Mineral oil is actually biodegradable in some cases, depends on who you buy it from, which one you go with. I certainly know Submer's product that we've got here is 100% biodegradable. Fantastic product. Environmental impact for the oil itself needs to be considered. Some are, as I said, some are not biodegradable. So if you get spillages, you've got to take that into consideration. And it requires more infrastructure because you need to bund the entire room. Hybrid systems. The biggest benefit of this, the use of mineral oil and water-based cooling offers enhanced temperature regulation. Believe it or not, our power systems that cool the immersion halls use a quarter of the power, if not less, just on the cooling side. That's just tick over. And it can be actually lower than that if we change the actual cooling trays. Heat capacity versus heat dissipation, okay? The two important factors to consider, okay, mineral oil versus water. On both of those, it gets a bit confusing, and I'll be totally honest, put this slide up there to remind me to say, when you're looking into this, it's worth picking those 2 points out. Your capacity is the amount of heat the medium can store. The dissipation is the speed and the capability of that liquid to get rid of the heat through a different medium. Then we go into chemistry, into the DC. It's a phrase that we coined, okay? How does it work? Bit of chemistry. We all go back to GCSE levels or O levels or CSEs, whatever you did. Molecules, elements, atoms, and protons. A molecule is comprised of atoms. An element is a pure substance containing of only one type of atom. An atom is the basic unit of matter, and a proton is only ever found within the nucleus. It's a subparticle. Now, there's a scale factor there. Physically, the molecule is the biggest, elements next, atom, and then proton is tiny. So that takes us into what are we? If we take something called an atom, that's what we're going to explain to you today. So the atom is a product which we have. At the moment, this data center isn't an atom, it's an element. Okay, it's what we've phrased it as. But an atom is tiny. It's much, much smaller. We can compress not only the server's text, but obviously with the vendor's help and the bath manufacturer's help, we actually compress the physical building. Now today, whilst you're walking around on the tour, you'll get an idea of the scale of the site with 37,000 square feet. Okay? An atom is 76 square meters, which, believe it or not, is smaller than this room. Yet, we can run between half a meg and a meg of power cooling in that and compute in that facility. So, that's the explanation of molecule, element, atom, proton. Yes, we do have them all. Element is here. Molecule is when we get a larger site which has got two elements together. Okay? Atom, small, and proton. Proton is dinky. It's something that you may want to set up in your offices for your engineers to do their pre-build, etc., and then they ship them out to the data centers. So, this is an atom. This is one which we actually worked with our partners at Sudlows, Submer, Intel. Everybody's been involved in this design. And what it is, 76 square meters. You will see it's colored. The green racks are self-contained dry racks. These little triangular ones and the little black ones on the bottom left, those are the immersion baths. They're the smaller versions of what we have here. These huge black tall things are the cooling systems. They're inside the building. Well, we can actually modularly swap out these. We can take out 100 kilowatts of dry rack, and in that footprint, we can put 200 to 300 kilowatts of immersion cooling. So that's my bit. I'm now going to open the floor to Steve, who's going to take you through the next part, which is all about the immersion cooling overview. Thank you very much.